In fact, we will have homework both for tonight and with WKCE testing. You actually have some homework for Tuesday that actually you consider it all today's homework. It'll all be due on Wednesday. So we don't meet again as a class until Wednesday. Hey, guys, stop talking while I'm talking. And if you're not going to stop, I'm going to just have to ask you to leave. Okay? These proofs are going to be, we're going to keep working on them, and this is the kind of thing that's going to show up on your WKCE. Some of this, at least it has in the past. We never know exactly what's going to be on this here. But it's pretty common to see proof type stuff on WKCE. So be prepared for that. You're going to see this. We are going to do one little new thing today that we're going to add. We're going to add, instead of congruent triangles being our finish line, we're going to get a new finish line. We're going to go just a little beyond congruent triangles, but that's not too hard to do. In fact, we're still basically doing the same thing. And even if you get stuck on that new finish line deal, just still try to prove triangles congruent. That's still your basic strategy. So, let's look at a proof. Given segment AB is parallel to segment CD, segment AC is parallel to segment BD, prove the triangles are congruent. All right, so let's start out. Now, we didn't do a lot of this yesterday. We talked about this, but this is kind of new. AB is parallel to CD. That's given. Okay, I should mark that. AB is parallel to CD. Now, when we have parallel lines, what are we looking for? Parallel lines and transversals, so we can get alternate interior or something, or some sort of special angle pairs, right? Okay? Well, with these parallel lines, what do I see? There's my Z, right? So where is my congruent angle pair? Angle BAD is congruent to angle CDA. So that's one angle pair that we've got there. What's the reason? What kind of angle pair is that? Alternate interior angles are congruent. Or alternate interior angles theorem. Okay? Name the angle pair plus, this time it's not a converse because we're not proving lines are parallel. We know the lines are parallel, so we use the word theorem. Name of the angle pair plus the word theorem. Again, we're right back to the idea of, do you know the name of that angle pair? We've had that 5 quizzes and tests in a row on the test. Guess what? It's going to be on the 6th one as well, because we're going to use it again. Some people still don't know their angle pair names. It's a problem. Okay? Next given. AC is parallel to BD. That's a different statement. It is given. And if AC parallel to BD. Same transversal, different angles. Don't they? Now what angles are congruent? Angle CAD is congruent to angle ADB. Okay? And again, same reason, alternate interior angles theorem. Okay? Mila, what is the third thing that you said we have here?
A shared side.
A shared side. No, there it is. So, AD is congruent to AD. What's the reason? Reflexive. Okay? So we mark that in. I didn't mark in my second pair of congruent angles. I should do that. Is that enough for congruent triangles? No, it's not side angle side. I've got... Okay, before we start shouting out answers, okay, and this is half the problem, folks, you can't start guessing and just throwing junk out there. Don't do it. Because both those answers were straight up guesses with no thought behind them. You might as well just write down, put an F on my paper. You've got to think before you speak or write. What do I have here? I have an angle. What do I have here? I have another angle. What do I have here? I have congruent sides. Now, I don't know if it's that order, if it's angle, angle, side, or if it's going to be angle, side, angle, but certainly it's not going to be side, 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 or side, angle, side, because I only have one side and two angles. So you've got to think before you open your mouth, or before you start writing things down. You got to look at what's there. If you're not willing to do that, you will not pass. Okay? Which one is it? Is it angle, side, angle, or angle, angle, side? It's angle, side, angle. And the triangle congruence statement is right there. We just copied that down. Triangle ACD is congruent to triangle DBA. There it is. There's our proof. So again, we see how parallel lines can be used to set up corresponding parts. But, like I said, thinking is key. Slowing down and actually evaluating. Guessing will get you very poor grades in this section. You have to know this stuff. Notice there's a rectangle up there. There's no triangles. How about that? Given GH is congruent to JK. Okay, let's see what we can do with this. I don't even have triangles in the picture, but that's okay. Let's get there. GH is congruent to JK. That's given. Let's mark it. GH is congruent to JK. Marvelous. HJ is congruent to KG. Given. HJ is congruent to KG. I want to prove that triangle GHK. Oh, I'm going to have to draw in the diagonal so I know where it is, aren't I? JKH. All right, I've drawn in the diagonal. Am I allowed to draw an extra line in there?
Yeah.
Oh, yeah. Nothing's stopping you from drawing a line between 2 points. We know that the line exists. Or segment at least exists. What would be my third thing, though? I've got a side here and I've got a side. What's my third thing going to be? KH is congruent to KH. Not equals, congruent, reflexive. Do I have enough now? Which theorem? Side, side, side. And triangle, GHK, is congruent to JKH.
What's that thing after the 4?
Side, side, side. Triangle, GKH. Triangle. Okay. So again, not too tough, but it required us to take a little bit of a different tactic. So now, PQ bisects angle SPT, and SP is congruent to TP is given. Okay? So let's go ahead and start this one, but this one we're going to take to the next level now. Prove that triangle APQ is congruent to triangle TPQ. It should be SPQ, sorry. A and S are next to each other on the typewriter? Or just typo?
On typewriter.
On the keyboard.
You type on a typewriter?
Yes.
I do.
I'm good like that. All right. So we're going to start with PQ bisects.
Angle SPE. Would that mean QT bisects angle SQT?
No. It is not. It does not go both ways necessarily. Okay? We might be able to get there eventually, right, Vinny? Stay awake. Head up. Come on. You're getting this stuff. You're doing it okay, but you need to stay awake. All right? Now, people have been having trouble with this because, again, you have to understand what a angle bisector is. An angle bisector is a ray that splits an angle into two smaller congruent angles. Splits the angle equally into congruent angles. If it's a segment bisector, splits a segment into two congruent segments. But I can't bisect an angle and wind up with segments. Like I can't get bananas from the apple tree. All right? I can't do, it doesn't work that way. But I've got too many people who, when they're coming in for stuff or I'm going over this with individuals, I say, what does it mean it's an angle bisector? I don't know. Well, what's congruent as a result? Well, these segments. How do you get congruent segments from an angle? You don't. Okay, it doesn't even make sense. That's guessing, that's not thinking through it. Let's think through it. PQ bisects angle SPT. This is the angle being bisected, okay, by that. Where are my congruent angles going to be? What do you get?
SPQ and TPQ?
Yep. It's really not hard when you take a second to think about it. And what's my reason?
Definition of midpoint?
No, definition of
Bisection.
bisects.
Oh.
If you said bisection, I'd be okay. But since we use the specific word bisects, that's the word I'm working with, I guess. All right? So that's definition of bisects. That's great. I've got that. So I've used that given now. And I've got some congruent angles. I marked them. Now, can we go with this? Can we say this is also congruent angles? No. No, we're not given that information. I don't know if that's a bisector of that angle or not. I might be able to figure it out later, but right now I don't know that. So that's not given information. Next, SP congruent to TP. Okay, that's given. We mark it in. Gosh, this is the third time in a row we've had the same thing. What do we have? Shared side. So PQ is congruent to PQ. Reflexive.
Has your board crashed yet?
Not yet. Doesn't matter. It's the same segment either way, right? Okay. What do I have? I have side, angle, side. Side, angle, side. So 5, I have triangle SPQ congruent to triangle TPQ, and we said the shortcut we use is side, angle, side. Now, here's where we're going today. This is the only difference that we're really throwing in here. What now? Now that the triangles are congruent, what else can we do? Well, now I can continue on. Now that I know the triangles are congruent, I know all their corresponding parts are congruent, right? Not just the ones I've known up to this point. So far I only have these 3 pairs of corresponding parts congruent. That's all I've known for sure. But now that I know the triangles are congruent, I know all the rest of the corresponding pairs have to be congruent, whether angles or sides. So now if I want to know that angle S is congruent to angle T, I could say yes, it has to be because because I've hit the congruent triangle point. Now angle S has to be congruent to angle T because they are corresponding parts of congruent triangles. And those are congruent. CPCTC is a phrase that we use all the time. Now, some important things about CPCTC. We can only use it after I know triangles are congruent, after a shortcut. Can I use it before a shortcut? When can I use it? After. Can I use it as a reason why? Can I use it as a shortcut?
No.
When do I use it?
After.
After the shortcut. And it stands for corresponding parts of congruence, lots of C words, triangles, more page, are congruent. Okay, now, people never forget that. So we do this the old-fashioned way. We all say it together as we're crashing from our sugar rushes, right, Jude? Yeah. Look up. Say this with us. Everybody say it out loud. It's going to help you remember it. I'll say it with you. Corresponding parts of congruent triangles are congruent. Let's do it again. Corresponding parts of congruent triangles are congruent. Let's do it once more. Corresponding parts of congruent triangles are congruent. You might want to write that down because, you know, it would be really shocking if that maybe showed up on a quiz sometimes. What does CPCTC stand for? Are congruent. Yes, sir, Mr. Kress.
I have an idea.
Yes.
Why don't we just say CPCTC?
That's what we do on the proof. I don't write this whole phrase on the proof because it's too long. I use the abbreviation, but we have to know what it stands for. Okay? It doesn't do us any good to say that if we don't understand what it means. We have to have an understanding of what that means. And really what this is a definition of, ooh, that was fun, congruent triangles. This is getting interesting.
Glitch out.
Yep. Really what that is a definition of congruent triangles. That's really what that is. So if you want to change it up, you could say definition of congruent triangles. That'd be okay too. But notice what we're doing is we're saying, okay, like I said, I knew these three parts were congruent, but now I'm actually going beyond that and finding, once I know the triangles are congruent, I can conclude the other parts are congruent. So a lot of times instead of saying now, prove the triangles are congruent, it might say prove angle S is congruent to angle T. Don't let that throw you off. We're still going to prove triangles are congruent. That's how we're going to start out every single problem. Come on, let's keep our eyes open. All right, sit up. It's going to help. I know. I don't want you to fall asleep. I want you to stay awake so you can learn this stuff. Because it's going to be important. All right, so, all right. And here it is again. Corresponding parts of congruent triangles are congruent. You're going to want to know that phrase. It's important. Again, it is not one of our congruent shortcuts. It is not one of our congruent shortcuts. It doesn't prove the triangles are congruent. We use it when? After congruent triangles. After congruent triangles we use it. It's almost always the reason we use right after congruent triangles if we're going beyond congruent triangles. Almost always. Okay. So here we go. Given AD is parallel to CE and AD is congruent to CE, we want to prove that, and it might just say this, AB is congruent to DB. Now, it doesn't say prove the triangles are congruent, but we're going to do that first. Don't worry, we're always going to start with proving triangles congruent in this unit. We always begin with that, and then we'll use CPCTC to go beyond. So, let's start out. Start our proof. AD is parallel to CE. AD is parallel to CE. Given. All right, so these lines are parallel. Well, I could have some alternate interior angles here somewhere, couldn't I? Like right there. Which angles are congruent? Angle C is congruent to angle D. Yeah, and there's only one angle C and one angle D, so I can get away with that. Okay. Alternate interior angles theorem. Okay. Now, this one's kind of an interesting one because we have a lot of choices. There are actually many ways we can go. I actually have with these parallel lines a second Z, don't I?
Yeah.
Okay. I have a second Z. Okay. Angle is not one of our shortcuts, though, is it?
No.
Unfortunately not. Now, I could use the second Z or I could use the vertical angles, but I don't need to use both. It's not wrong if you use both, but you don't have to. So I'm going to say angle A is congruent to angle E as my second one. Okay, again, same reason. Alternate interior angles theorem. Same reason. Okay? Now, from there, once I have two angles, I never go for the third angle. Because angle doesn't help me. Okay? Once I have two angles, I never go for the third angle. Now I look for a side. But which side do we have? Oh, it's a given! Happy day! AD is congruent to CE. Angle side angle is my shortcut to show that, now we got to get it in the right order, ADE triangle is congruent to triangle. Now A went with E, so, and D went with C. B. I'm sorry, ADB. This is a B. My bad. I know it. I wrote over it. That's why.
No, I can't see it there. I mean, like, I can't even see the letters.
That's a B.
What's the other letters?
Okay. ADB, ECB. All right. Now, but that's not what I wanted to prove. I wanted to prove that AB is congruent. I'm sorry, that's not even right. Wow. AB is congruent to BE. Okay. AB is congruent to BE. And sure enough, AB is congruent to BE. AB to BE because of, what's the reason?
Reflexive.
Oh, CPCTC, which stands for parts of congruent triangles are congruent. There we go. Corresponding parts of congruent triangles are congruent. The second two C's are congruent. The first one is corresponding. Okay. Let's have the phone. Thank you. Man, I tell ya. We've talked about it and talked about it and talked about it. All right. Let's go. Keep going. Prove angle A is congruent to angle C. We're out of here at 11:02. We got just enough time. We're going to get through it quick. All right. PB is perpendicular to AC. Given. What does it mean that it's perpendicular? That means it forms right angles, so angle ABP and angle CBP are right angles. Okay? Definition of perpendicular. Why might I need to know that? Because maybe with right angles I might be going for HL. Okay? I don't need to know, I could say they're congruent as well, but I don't need to know if I need to yet. So I'm going to do AP is congruent to PC. Okay? That's given. And PB is congruent to PB. What would be my reason? Reflexive. So that's congruent to that, and that's congruent. That is HL. So triangle APB
That's a lot of work.
is congruent to triangle CPB. We got HL. But that's not what I want to prove. I want to prove angle A is congruent to angle C, but angle A and angle C are corresponding parts. So 6, angle A is congruent to angle C, CPCTC. Okay? I think it's the week, I think it's like,
Weeks from, or a week from tomorrow, or
yeah, it's 2 weeks from Monday.
just say not.
So, all right. I'm going to export my notes before this thing crashes.
What's 2 weeks from Monday?
Next late.